Hi all, very happy new year to all of you. From today onwards, we are starting off with the revision series in which we'll discuss most of the questions, the PYQs, okay, and some of the very important practice questions, including the concepts, okay. We are going to see some minute, there are some minute concepts are there from which questions can be asked. So we are going to cover all of them, okay. Let's start with the series. So in this section of calculus, you will find there are various minute concepts are there from which questions are asked, okay. Majorly the part of calculus starts from the chapter of limits only, limits, continuity, differentiability, and so on. But we actually, what I do for my students, actually I start the calculus part with functions. I treat functions to be a part of calculus, but here we are starting off with the calculus part from limits only. We are starting off with the calculus part from the part of limits only, and we're going to discuss the core calculus first, and then I'll take a separate session where I'll put the questions on functions, okay, and that will be known as pre-calculus. Now we won't discuss concepts separately. As we do the questions, we'll see the concepts parallelly, okay. Let's start with the very first chapter of calculus, which is limits. Here comes the first question. Some basic idea of limits you must be having. So based on this only, we will proceed. Since some standard limits, all those things are there which you have learned in limits. Standard limits, standard forms are there, okay. 7 indeterminate forms are there. Those standard forms are important, okay. Anyway, so here we start with the first question, which says that limit n tends to infinity, and we have this entire limit. This is given to be 1/3. X belongs to what? We have to find the range of values of x, okay. So first of all, here in this question, the answer of this limit is given. Answer of this limit is given, right? Answer of this limit is given. We are not asked to find the limit or solve the limit. We have to find the values of x, which is inside this limit actually. So let's see, first of all, focus on the right hand side. Right hand side, we have 1/3. Now 1/3 in the numerator, we have 1. Now 1/3, here we have 1/3 on the right hand side. So 1/3 means in the numerator, you can focus on there is a 1 over here, which means anyhow, basically somebody might have solved this limit and the answer would have been 1. Answer would have been 1/3. Means in the numerator, to obtain 1, first of all, you have to make 1 over here. How can we make 1 in the numerator from the left hand side? So definitely, one thing I can think of is limit n tends to infinity, n times of 3 raised to the power of n. I'll try to take out n times of 3 raised to the power of n common from the denominator. So that this n times of 3 raised to the power of n and this n times of 3 raised to the power of n, both will cancel and will obtain 1 in the denominator, in the numerator. Okay. So what I do is I'll take out n times of 3 raised to the power of n common from the numerator. Fine. So what I do from here, once I take out common, what we have from here? X minus 2 divided by 3 raised to the power of n. Okay, we are taking n times of 3 raised to the power of n common, plus n times of 3 raised to the power of n plus 1. So 3 is remaining, and from here what is left out? 1/n, right? Because we have taken 3 raised to the power of n common, and n also we have taken common, so 1/n is left out. This thing is left out, and on the right hand side we have the answer to be 1/3. This quantity and this quantity both will cancel out, okay. Now here limit n tends to infinity, and so as n tends to infinity, you all know 1/n will tend to 0. This part will tend to 0, and if this part tends to 0, so you are only left out with limit n tends to infinity. We are left out with this part, 1 upon x minus 2 divided by 3 raised to the power of n plus 3. 3 is a constant, there is no problem. Now on the right hand side, we also have in the denominator, we are having 3, right? So we have to bring 3 in the denominator. After putting the limits, here we have n tends to infinity. Here we have n and n tends to infinity. Now anything raised to the power of infinity, tends to infinity unless we have a proper fraction, or in fact, more specifically speaking, we have this quantity. Look at this. Here we have 1 upon x minus 2 divided by 3 raised to the power of infinity plus 3. This quantity on the right hand side to be a finite quantity, means 1/3. To obtain 1/3, this quantity has to tend to 0. This quantity has to become 0. This quantity will become 0. And here we have power. In the power, we are having infinity. This is only possible. If x minus 2 divided by 3. In fact, the mod of this In fact, the mod of x minus 2 divided by 3 is what? Less than 1, right? Less than 1. Or more specifically, x minus 2 divided by 3 lies in between minus 1 and 1. Then only you will figure out that this quantity, whenever you are raising this thing, whenever mod of something is less than 1, and you are raising that quantity to the power of infinity, that quantity will lie in between minus 1 and 1. You will find that whenever we are taking modulus of some quantity, and that quantity is less than 1, mod of that quantity is less than 1, which means the quantity is lying in between minus 1 and 1. Anything which is lying in between minus 1 and 1, and when you raise the power to infinity, that will tend to 0. That quantity will tend to 0, means this will tend to 0 if and only if this quantity lies in between, this quantity x minus 2 divided by 3, the absolute value will lie in between minus 1 and 1, or rather more specifically, the value lies in between minus 1 and 1. Okay, then only you will figure out this thing. Now we can simply solve for x from here. So minus 3 lies in between x minus 2, minus 3. So x minus 2, we just need to simply remove this 2. So we add 2 over here. So minus 1, x lies in between, and 5, right? Fine. So where does x belongs to? X belongs to minus 1 to 5. These are the values of x. Fine. Let us move to the next question. Now, before we solve this question, I hope you know the standard limits, some of the standard limits which you should be remembering. Let's recall quickly, like the standard ones, standard limits, limit extending to 0, sin x upon x. First, we have the trigonometric limits. Then we have the log limits, limit tan x upon x. This is also a trigonometric limits. These are some standard limits which you should be knowing. Limit extending to 0, 1 minus cos x divided by x square is basically half. Then we have the exponential limits, limit extending to 0, e raised to the power of x minus 1 divided by x, which is actually 1. And then we have the logarithmic limits, which is limit extending to 0, a log 1 plus x divided by x, and this is equal to 1. All these are some standard limits which you should be knowing. And how do we represent, actually, how do we identify these forms are actually very, very important. How do we identify these forms are very, very important. Likewise, here we have always, you won't be facing this thing. Always you won't be facing sin x upon x or tan x upon x. You can simply face sin 2x upon 2x also, sin 2x upon 2x, and limit extending to 0. The idea must be, here we have the same quantity and here also we have the same quantity. And upon putting the limit, whatever is the limit, when you put the limit, these quantities must tend to 0. These quantities must tend to 0. Similarly over here also, on putting the limit, these quantities must tend to 0. This quantity and this quantity. And we must be having the same by same format, means sine of same divided by same. Sine of same divided by same. Sine of same, sine of whatever it is divided by the same quantity. And upon putting the limits, this same quantity must tend to 0. Or whatever is the limit, upon putting the limit, the quantity must tend to 0. Okay. Now, one more thing to start off with, before we start off with any question, before we start off with any limits question, which involves solving the question, solving the limits, you must focus on the question first. When you read the question, you must see that, you must check which form is this. Which form is this? 0 by 0 form, infinity by infinity form. Which form is this? You put the limits over here, limit extending to 0. You put the limits over here. So cos square 1, cos square 0, cos 0 is 1, 1 minus 1 is 0. Similarly over here also. Here we have in the numerator, we have 0. And here, once you put the limit over here, this will become cos 0, 1. But this quantity will become log 1. Log 1 will, log of 0 plus 1. So log of 0 plus 1 is what? 0. Log of 1. So log of 1 is what? 0. So 0 by 0 form. This quantity is 0 by 0 form, means this limit, first you need to check the form. Which form is this limit based on? This limit question is based on. So 0 by 0 form. So now once we are done checking the form, now we solve the question. Like here we have limits tending to 0. X is tending to 0. So first what I can see is we have 1 minus cos square x. So the first thing is what? We can change this to sin square x. Limit extending to 0. Sin square x. So sin square 3x. Okay, and this sin cube 4x and cos cube 4x this will make out to tan cube 4x, right? Okay. And here we have log 2x plus 1 raised to the power of 5. So we separate this thing. So 1 upon log 2x plus 5. So 1 plus 2x. Okay. 1 plus 2x raised to the power of 5 whole to the power of 5. Now, before we see this thing, you just figure out what are the standard forms. Can we bring into some standard forms? Definitely yes. We can see tan cube 4x over here. So what we can do is we can divide by 4x cube. Why we divide by 4x cube? This part, this entire part will become tan 4x upon 4x whole cube. Tan 4x upon 4x whole cube. Okay. Now, because we are dividing, we have to multiply also to balance this. So 4x cube we have taken extra. Similarly, here also we can take 3x square extra. 3x square we can take extra. Okay, we can take 3x square extra. So we are taking 3x square, 3x whole square extra. So we have to multiply also. We are dividing by 3x square. So we have to multiply also. And similarly, log 1 plus, now see 1 plus x, log of 1 plus x divided by x, and limit is x tending to 0. This is always 1. So similarly, here we have log 1 plus 2x. We need to bring the same by same, same by same. 1 plus same divided by same. So same quantity. So I divide by 2x. I divide by 2x, so I have to multiply by 2x also here. Right? In fact, here we have raised to the power of 5. So 2x raised to the power of 5 we have to divide with. We have to divide with 2x raised to the power of 5. This thing, entire thing raised to the power of 5. So we are taking extra 2x raised to the power of 5. Okay. Now you see from here, as x tending to 0, as x tends to 0, this part will also tend to 0. So same by same, this part will show as this part will also tend to 0. So same by same format we are having. So this quantity will become 1. 1 square is 1 only. This quantity will become 1. This quantity will also become 1. All these quantities will become 1. So you're left out with only this part. So 4x cube, 4x whole cube into 3x whole square divided by 2x whole to the power of 5. And limit also extending to 0. We put the limits over here. I think here we have some cancellations. You can clearly see x cube and this x square will make it to x to the power of 5, and this x raised to the power of 5 will get cancelled. So you're left out with only the constants. We have this 4 cube, which is 64 into 3 square, which is 9, and divided by, here we have 2 raised to the power of 5, which is 32. Okay, so this 32 and this will go up. So we have 2, 9 times of 2, which is 18. So 18 is the right answer. Fine. This is a very basic question, you can see. Let us move to the next question. Okay, now we have this question. This question is based on limits, solving limits using substitution. Focus on this question, which says that limit x tending to 2, and here we have some exponential functions given, exponential numbers given, like 3 raised to the power of x and 3 raised to the power of 3 minus x and so on. So the best thing, what we can do is we must simplify this thing. Just figure out this thing. We have limit x tending to 0, x tending to 2, 3 raised to the power of x plus 3 raised to the power of 3 minus x, which we can write it as 3 raised to the power of 3 divided by 3 raised to the power of x. Okay, minus 12 divided by 3 raised to the power of minus x by 2. Similarly, this also we can write this as 1 upon 3 raised to the power of x by 2, 1 upon 3 raised to the power of x by 2, and this quantity is minus 3 upon 3 raised to the power of x. So in overall story, we are having 3 raised to the power of x and 3 raised to the power of x by 2. So to make this a much more simpler, what I do is I'll take one of them to be t. Which one I'll take? I'll take 3 raised to the power of x by 2 to be t. I'll take this to be t. The smallest one. You take the smallest one to be t. Why? Because you can clearly see once you square this, you will be obtaining t square. And here on the left hand side, this 2 and 2 will get cancelled. You are left out with 3 raised to the power of x. So automatically 3 raised to the power of x will also get reflected. So what you can do is you can simply now transform this thing in terms of t. So this part is t square plus 3 cube. So 27 divided by 3 raised to the power of x, which is t square, and minus 12 divided by 1 upon 3 raised to the power of x by 2, which is 1 by t, and minus 3 upon t square. Okay. And also, because we have taken a substitution, so we have to also simplify the limit in terms of t. Also, we have to simplify the limit in terms of t. So as x tends to 2, so t will now tend to 3. Clearly see from here, we have x tending to 2, so 2 by 2 will become 1, so 3, so t is 3 now. So as x tending to 2, t will now tend to 3. So now we solve this limit now. Now this becomes much more simpler. So limit t tends to 3. So now we simplify this thing. So once you take the LCM, this t square and t square will get cancelled. So you're left out with what? T raised to the power of 4 plus 27 minus of 12 times of t square. Okay, divided by, here we have t square, 1 upon t minus 3 upon t square. So this will become what? T minus 3. This will become t minus 3. Okay, got it? So now we try to factorize this thing. You can clearly see that it is factorizable, and it's a quadratic in t square. It's a quadratic, almost specifically biquadratic, but it's a very basic quadratic in t square. So we try to factorize this thing. So once you factor this thing, you will be obtaining t tending to limit t tending to 3. You try to factor this thing. So this will become t square minus 9 times of t square minus 3. You can factorize and check. T square minus 9 divided into t square minus 3 divided by t minus 3. So once you factorize this thing, you will be obtaining this thing. And further you factorize this, like t square minus 9 is basically t plus 9, t plus 3 times of t minus 3. So one of this will get cancelled out, t minus 3 and t minus 3 will get cancelled. So you're left out with what? Limit t tends to 3. You're left out with t plus 3 and t square minus 3. Now simply put this over here. So limit t tending to 0. Okay. So once you simply put the limit, so this will become what? 9 minus 3, which is 6, and this will become 3 plus 3, 6. So 6 into 6, 36. 36 is the right answer. Now let's move to the next question. Look at the next question. I'm keeping this question for your homework. You can clearly see this question was asked in KVPY SX 2015. So can you see over here? It's just the similar problem which we have done right now. It's a similar problem. Only in the place of A, in the previous question, they have given the question which was asked in JEE Mains 2020. So the question, the inspiration to design this question came from here only. The inspiration to design the question came from here. Okay, this question was given in KVPY SX 2015. You can clearly see that here we have A and 3 raised to the power of minus 3 minus x, and so many things are given. So here we have the same question. This was the same question, similar question. Only they have simply replaced A by 3. Okay, so just like the similar way, you can solve this. Yes, you can use the L'Hopital's rule also. You can use the L'Hopital's rule also. You can use the L'Hopital's rule as well. Okay, I'm keeping this question for your homework. You'll try out this question for your homework. Let's proceed to the next question. Okay, next we have this question from JEE Advanced 2020. They're asking you to calculate the value of this limit extending to pi by 2, this thing. Entire huge expression in trigonometry has been given. So once again, this is also a question which you can figure out. It's a question based on trigonometric simplifications. You just have to use the basic simplifications. You can check the form. It's 0 by 0 form. Clearly, this can be seen. So anyways, so we have to solve this using the trigonometric simplifications. You can see this entire huge expression is given. Okay, and what I do, I start simplifying this thing. Like in the numerator, we are having limit extending to pi by 2. In the numerator, we are having 4 root 2 times. We can use sin c plus sin d formula to simplify this. That's what we can think of. We can simply use sin c plus sin d formula. So 2 sin c plus sin d means 2 sin cos. 2 sin and cos, right? 2 sin cos. First of all, then 2 sin c plus d by 2. 3x plus x, 4x divided by 2 means 2x. And 3x minus x, which is 2x by 2, which is x only. And divided by here, what we have. Now let's see the denominator. Now here, there comes the main part of simplification. One thing I can clearly see, I can use once again cos c minus cos d formula from here. And from this part also, I can take out root 2 common, right? So, and let this be fixed for the time being. We can simplify this later on. We have 2 sin 2x, okay? And then we have this part, sin 3x by 2. Now cos c plus cos c minus cos d. Let's use cos c minus cos d. So cos c minus cos d means special formula, 2 sin. So 2 sin c plus d by 2 into sin d minus c by 2. So 2 sin c plus d by 2, 2 sin first of all. Is the special formula. I hope you know this thing, that 2 sin c plus d by 2 plus sin d minus c by 2. So sin c plus d by 2, 5x plus 3x, which is 8x, 8x by 2 divided by 2. So 8x by 4, which is 2x. And similarly, sin d minus c by 2 means sin Sine of 3x minus 5x, which is minus of 2x divided by 2 and divided by 2. So minus of x by 2, and simply take out this minus sign and we can take it out here and we can simply write this as x by 2. Sine of minus x is minus of sine x. So I've simply taken this outside, this minus sign. So we are left out with this, and then we have root over of 2. So we can take out root over of 2 common from here, right? So we are left out with what? 1 plus cos 2x. Now 1 plus cos 2x is basically 2 cos square x. Okay, that's what we are having. So we can see some sort of simplification from here, that we have limit extending to pi by 2, and here we have 8 root 2. In the numerator we are having 8 root 2, and this becomes sine 2x. We can further break this also. Sine 2x is basically 2 sin x into cos x. We'll simplify this as much as possible. 2 sin x cos x and multiplied by cos x, so cos square x divided by, and in the denominator we can break this, like 2 sin 2x is there. So from here, this entire part we are getting 2 sin 2x common. So once you take out 2 sin 2x common, you are left out with sin 3x upon 2. Sin 3x upon 2, and here we have minus of sin x upon 2. Right? Sin 3x upon 2, this one, and then minus of sin 3x sin x by 2. That's what we are having. And minus of root 2 times 2 root 2 times cos square x. That's what we're having. So now what we can do is we can further simplify this. Let's simplify this further. Let's simplify this sin c minus sin d by the sin c minus sin d formula. So what we get? Just see this part. So 2 times of sin 2x. Now sin c minus sin d. So sin c minus sin d. So 2 sin sin first of all. Sorry, 2 sin cos. 2 sin cos. Right? 2 sin cos. Then we have 2 sin c minus sin d. So we have sin c minus d by 2, means 3x minus x, which is 2x by 2, right? Which is x by 2, right? And similarly, here we have 3x plus x, which is 4x by 2, which is 2 only, 2x by 2, which is x only. So this is what we are getting. 2 sin c minus d by 2 into cos c plus d by 2. So minus of 2 root 2 cos square x, which was left out. Okay. And from the numerator, we are getting 8 root 2 sin 2 times of sin x. So 2 times of 8, make this as 16. Make this as 16, and this is 2 sin x into cos square x, right? And limit x was tending to pi by 2. That's what we are having. So next, can we see from here that we are getting some sort of simplifications? Let me write this more clearly. So this is actually 16. So 16 times of root 2 sin x into cos square x. So what we can see, we can take out cos x common from here. Cos x is getting common from here, right? Cos x is getting common from here. You can clearly see one of the cos x will get cancelled. This cos x will get cancelled. Cos x will get common from here. One of the cos x will get common from here, and cos x, one of this will get cancelled, right? So you're left out with 16 root 2. You can simplify this also, like 16 root 2 times sin x. From here also you can take out 1 2 common, right? From here you take out 1 2 common. You take 1 2 common from here and cancel out. So 2 times 8. Okay. So this reduces itself to 8 root 2. We can further simplify this thing. Like here we have 1 cos x over here. So we can further simplify this. Likewise over here we have sin 2x, right? So sin 2x is there. So further we can break that into 2 sin x into cos x. Let's break it. Let's simplify this further. Limit extending to pi by 2. So here we have in the denominator, we can simplify this as 2 sin x into cos x, right? 2 sin x into cos x, this sin 2x. Okay, and then further we have inside, we have 2 sin x, 2 sin x by 2, and minus of root 2 cos x, minus of root 2 cos x. And in the numerator, we are having 8 root 2 sin x into cos x. So further, you can see that this cos x once again will cancel out. This one of this cos x, you can take out common cos x, and this cos x will also cancel out. So what you're left out with? You're left out with limit extending to pi by 2, 8 root 2 sin x, 8 root 2 sin x divided by 2 times of sin x multiplied by 2 times of sin x by 2. So that is actually 4 sin x into sin x by 2, sin x into sin x by 2. And here we are getting minus of root 2. So now we can simplify from here. We can simply just put the limits over here. That's all. Now we can simply put the limits. Now limit x tending to pi by 2. So this will become what? 8 root 2. 8 root 2 into sin 90. So which is 1 divided by 4 times of sin 90, which is 1, into sin pi by 2 divided by 2, which is pi by 4, which is 1 by root 2. right? 1 by root 2 and minus of root 2. Minus of root 2. That's what we're having, right? So 4 times of 1 by root 2 minus of root 2, which is ultimately this will become what? If you take the LCM, this will go up and become 8 times of root 2 into root 2, which is 8 times of 2 divided by 4 minus 2, which is 2 only, right? So what is the answer? Answer is 8. Fine. Answer is 8. Okay. So this is a question purely based on basic simplification. That's all. It's just a question based on basic simplification. You have to simplify using trigonometric identities, some of the very basic which you all learned, sum to difference formulas, okay, sum to product, then product to sum, all those formulas which you all learned, it's based on this only. So either the questions are more or less based on this formula, the questions are based on trigonometric simplifications, the questions are manipulation based questions, okay. These are some selected areas from which you are supposed to get the questions, okay. You know, there are some selected areas from which you get the questions. Like I have said, either you bring it to some standard forms of the limit, like sin x by x, tan x by x, all those are some standard forms, likewise what we have learned previously. Either you bring into the standard forms and simply solve in that way, or the questions can be asked from different sections. There are various sections from which the questions can be asked, okay. Likewise, we are trying to cover all the sections over here. So some of the sections which are left out, we are going to cover in the upcoming videos. Okay, let's move to the next question. Let's see what this question says. Once again, a question from JEE Mains 2023. Limit h tending to 0, root 3 times of sine pi by 6 plus h and minus of cos pi by 6 plus h. The moment you see this format, first of all, you are supposed to check the form. Limit h tends to 0, root 3 times of sine pi by 6 minus of cos pi by 6. It's 0 by 0 form. Clearly, this is visible, right? 0 by 0 form. Sine pi by 6 is what? Sine 30. Sine 30 is what? Half root 3 by 2 minus of cos pi by 6, which is cos 30, which is also root 3 by 2. So root 3 by 2 minus root 3 by 2, which is 0. So 0 by 0 form, right? And so what I do, the moment you see this format, it's a very well-known format. This should be known to you. The moment you see this format, a sin theta minus b cos theta, or let's say whatever it is, basically a cos theta minus b sin theta, or a sin theta plus b cos theta. These are very well-known format, and these type of simplifications are already taught in class. These type of simplifications, when you do trigonometry or when you do calculus even, these type of simplifications are taught in class. The moment you see this format, the first thing which strikes to your mind is what? To convert this root 3 as what? Some known format. So what we do here? So here we have root 3. So the moment you see this format, the first thing is what? You bring into some standard format. See, here we have sin pi by 6 plus h. So this thing clearly gives on one idea that here we have to multiply and divide by 2. If you multiply and divide by 2, so this will become what? Root 3 by 2 times of sin pi by 6 plus h and minus of cos pi by 6 plus h. That's what we'll have. And divided by root 3h into root 3 cos h minus of sin h. What is the benefit over here? This part will become, look at this part will become what? Cos pi by 6. Yes or no? This part will become what? Cos pi by 6. And this part here we don't have any coefficient. Here also we are dividing by 2. Sorry. Here we don't have any coefficient. So coefficient was basically 1. So 1 by 2. So here we have 1 by 2. So 1 by 2 means what? Sin pi by 6. 1 by 2 means what? Sin pi by 6. Right? Sin 30. So what I do? So here I simply use this format, that cos a sin b, or rather sin a cos b minus cos a sin b, which is the formula of cos sin a minus b. So this becomes 2 times of sin a minus b. So sin a minus b, sin a minus b formula we are having, divided by root 3h into root 3 cos h minus of sin h. All the way we are following limits. You must carry forward the limits. Limit h tending to 0. Limit h tending to 0. So here this part, pi by 6 and pi by 6 cancels out. We have sin h divided by h. In front we have 2 by root 3. We can simply separate this out. So we have 2 by root 3 times of limit h tending to 0. We have sin h by h. Sin h divided by h times of root 3 cos h minus of sin h. Now we can separate the limits. This part is a known format, sin h by h. So this limit will tend to 1. Now what about this part? 1 upon root 3 cos h means root 3 cos 0, which is 1, and minus of sin h, so which is sine of 0. which is straight away 0. So we have 2 by root 3 multiplied by 1 by root 3 minus 0, which is 1 by root 3 only. So 2 by root 3 multiplied by 1 by root 3, which is 2 by 3. So what is the answer? 2 by 3. Okay, so these kind of formats are also very, very important. So far, you must have seen that we are just simply using the basic trigonometric formats or trigonometric simplifications. These things are basically directly of questions of, more or less, questions of trigonometric simplifications. So kind of also we are practicing those kind of formulas also, which we might have learned in trigonometry. Sum to differ, sum or sum to product or product to sum, all those formulas what we have learned. We are kind of revising all the formulas and concepts over here, along with the chapter of limits. Let's move to the next question. Okay, now we have this question from ISI 2023. It says we have to solve this limit. Look at this. This is a very, once again, a very well-known format. These kind of formats are asked in ISI also, in JEE also. A very well-known format, I'm telling you. A very well-known format from which questions are asked. As limit extends to 0, you have this thing. Very carefully see how they have designed the question. We have 1 by x times of cos x, then cos 1 by x, and then we have the product of the first two terms. Here we have the cos x, here we have cos 1 by x, and then we have minus of cos x into cos 1 by x. The product of the first two terms are given. So kind of, if you, let's say, if you consider this to be A and this is B, then this is AB, right? And then we have one constant given, minus 1. So minus AB and minus 1. These type of simplifications are taught in class, in limits. What we do is basically these kind of, whenever we say that whenever you see these kind of formats, what type of formats? A plus B plus AB or plus 1, or let's say A plus B. Here they have given minus AB minus 1. Whenever you see these three terms, A, B, AB and 1, so you think of factorization. Obviously we have to factorize. A very well-known format from here. There has been lots of questions in JEE also and in ISI also. This is a recent year question, you can see. A plus B, AB and then 1. A, B, AB and then 1. That's how they'll give the format. So we have A, B, AB and 1. So which means we have to factorize this. So once, if you, for instance, you consider this to be A, that's B and that's AB. And here we have minus 1. So A plus B minus AB and minus 1. So once you factorize this thing, what will I get from here? You combine these two terms, A times of A and minus AB. So you take out A common, so we have 1 minus B. And from here also you take out minus 1 common, so this will become what? 1 minus B. So you're left out with A minus 1 multiplied by 1 minus B, right? And what was A? A was basically cos x minus 1 into 1 minus cos x. 1 minus 1 by cos x, cos 1 by x. Okay, and in front we had limit extending to 0. 1 by x means divided by x. That's what we have. So this question is now reduced to this. The question is now reduced to this now. So we have limit extending to 0. Limit extending to 0, cos x minus 1. Now you can clearly see 1 minus 1, 0. So it's 0 by 0 from question. So cos x minus 1 multiplied by 1 minus cos 1 by x. So what should I do over here? I know the format. I know the standard limit. Limit extending to 0. 1 minus cos x divided by x square is basically half. But here we are having cos x minus 1. So what? We can take out one minus sign common. We can make this as 1 minus cos x. But here we don't have x square. Instead we have x. But here we don't have x square. We have x. So what I do? I divide by x square. So we take forcefully, we are dividing by x square. So we have taken one extra x over here, which we are dividing with. So we have to multiply also to balance this. So x times of 1 minus cos 1 by x. Right. So what are we getting from here is limit extending to 0. This part, look at this part. This part will become what? Minus half. This will become minus half. Only this part will be remaining. So limit extending to 0. Now you can simply distribute the limits to this. You can simply distribute the limits. This part is now gone. That's straight away minus half. Minus half times of limit extending to 0. You're left out with this part. X into 1 minus cos 1 by x. Now see, as x tends to 0, cos 1 by x, or rather 1 by x, will tend to infinity. Right? Cos 1 by x will tend to infinity. Means this will be a very large number. This will be a very large number. So cos infinity. But you know the range of cos x. What is the range of cos x? Cos x always, whatever the cos x is, cos theta always lies in between minus 1 and 1. So this will be a very large number and this will oscillate in between minus 1 and 1. This will be a very large number, and this will oscillate in between -1 and 1. So it's kind of an oscillating number, finite oscillating number in between -1 and 1. So 1 minus oscillating number will give you an oscillating number as well. So 1 minus some finite number you will be getting from here. So 1 minus finite number will be a finite number. And in front we are having 0. So 0 into finite number. Look at this. 0 into finite number. Once you put the value of x tending to 0. So put the value of 0 over here. So 0 into some finite number. Finite oscillating number. Finite oscillating number in between -1 and 1. 0 into finite oscillating number in between -1 and 1 will be what? 0 only. 0 into any finite number is 0 only. So minus half, in front we had a minus half. So minus half times of 0 will be also 0. So what is the value of this limit? 0. Okay. This is a very well-known format. I'm telling you, these are once again very hidden formats given. These things we all teach in class, that a plus b minus ab minus 1 or a plus b plus ab plus 1. You just focus on these terms. A is there, B is there, AB is there, and 1 is there. A, B, AB, and 1. Focus on these 4 terms only. Okay. The 2 terms are given. 2 terms are given. Then the product of the 2 terms are given, and then 1 is given. Okay. Okay. Let's move to the next question. Okay. Next we have the question from JEE Advanced 2014. It's a very famous question. And it's one of the most controversial questions of that time actually. Anyway, so here we have the largest value. We are asked to find out the largest value of the non-negative integer a for which this limit exists, and this is equal to 1 by 4. We don't have to solve the limits. The limit has already been solved, and somebody has solved the limit and given the answer to be 1 by 4. They have asked to calculate the value of a. So what is this? First of all, if you figure out that here we have limit x tends to 1, you check this. This is 0 by 0 form. This inner bracket part is 0 by 0 form, and this is also a 0 by 0 form given. As you put the limits, limit x tends to 1, this is also 0 by 0 form, and this part is also 0 by 0 form. So kind of you can say that 2 different limits are given. We have to solve these 2 limits. So first of all, what I can see over here is limit x tends to 1. Let us simplify this first. We have some bigger term. We can simplify the powers easily. Why? 1 minus x is basically 1 minus root x whole square. So in fact, we can write this as what? Root x plus 1. 1 minus 1 plus root x into 1 minus root x. Right? So kind of you can say this part we are dividing by 1 minus root x. We are dividing this part by what? 1 minus root x. So when you divide by 1 minus root x over here, this will get cancelled out. You're left out with 1 plus root x only. So the index, the powers are getting simplified easily. 1 plus root x. The power is getting simplified easily. Now we have this part. Minus ax plus sine x minus 1 plus f. So what can we do for this? One thing which I can think of, first of all, here I can take a common. Here we have minus ax and here we have a plus a. So what we can do, we can take a common and this becomes 1 minus x and plus sine of x minus 1. Okay. Similarly, in the denominator also we are having some terms of x minus 1. So we take out this common. So here we have plus sine of x minus 1. The workings are pretty simple for this question, and this limit must equal to 1 by 4. So what I do, so from here we have limit x tends to 1. Now you see from here, as you put the value of x to be 1, here we have this will become 0, this will also become 0. So the best thing what I can think of is here we can bring into some standard formats like the sine x minus 1. So we can divide by x minus 1. So that sine x minus 1 and divided by x minus 1, that will tend to 1 when you put the limit x tends to 1. What I'm trying to say is this, that if you divide by x minus 1, so this will become what? A, right? Minus a. In fact, you are dividing by x minus 1. Here we have 1 minus x. So minus a plus sine of x minus 1 divided by x minus 1. And here we have divided by x minus 1 divided by x minus 1, which is 1, and 1 plus sine of x minus 1 divided by x minus 1. That's what we're having. And in the powers, we are having 1 plus root x. So now can you see from here, when you put the limits, limit x tends to 1, this part will become 1. This limit will become 1 because limit x tends to 0. Sine x upon x, sine of x upon x is basically 1. Sine of same by same, sine of same by same, sine of same by same quantity. And that same quantity must tend to 0 upon putting the limit. Here we have x tends to 1. If x tends to 1, x minus 1 tends to 0, basically. or rather x tends to 1, all these things will tend to 0. This will tend to 0. This will also tend to 0. Sign of same by same format. So definitely this will tend to 1. So as this will also tend to 1. So ultimately you are left out with 1 minus a in the numerator and divided by 1 plus 1, 2. And when you put the limits over here also, like in the powers, we are having 1 plus 1, which is whole square. And on the right hand side, we have 1 by 4. So technically, you will be getting two cases from here. One is for 1 minus a divided by 2 when you take the square root. So this will become 1 minus a divided by 2. 1 minus a divided by 2 is basically 1 by 2. One case is this, and the second case will be 1 minus a divided by 2 will be minus of half. Then we have the second case is this. Two cases, definitely. And when you are taking the square root, so this will come up at what? Plus minus square root of 1 by 4. This will be plus minus square root of 1 by 4. So 2 and 2 cancels out. So here we are left out with one of the value here will be 0. And from here 2 and 2 similarly cancels out. So one of the value is what? 2. So two possible values we are getting, a is 0 and a is 2. Now one confusing part is basically they have said purposely, just to confuse you, they have said the largest value of the non-negative integer a. Now you find out these two values and you mark the answer to be 2, then you'll go wrong. Okay, you have to verify over here also. Like, is this solution getting satisfied over here? Be very careful. If a is 0 and a is 2, okay, do not read the question and thoroughly, just simply mark the answer as 2. What will happen over here is, if you put the value of a to be 2, this will become 1 minus 2. This part will become negative, right? But negative whole square is defined. Obviously, negative whole square is a positive quantity. You know, this whole square is given, this square quantity, this degree which is there in the powers, this is not exactly 2. This is not exactly 2. This is something tending to 2. So tending to 2 means, let's say from one side we are tending to 2 means 1.9999 something, right? Kind of, you can think of this way, 1 minus a divided by 2 raised to the power of 1.9999 something means 19999 divided by 1000, let's say. Or let's say, let's take some more values, 999 divided by these many zeros we are having. So kind of this fraction, it's not exactly 2, it's tending towards 2. And that is what we have the basic definition of limits. As x tends to 1, this is tending to 1. Root x is tending to 1. Right? X is tending to 1. Root over of 1. Root over of tending to 1. Tending to 1, basically we are having 1 plus tending to 1. That is tending to 2. Okay? We write it as exactly 2, but that is not exactly 2. That is tending towards 2. So here what we do, we cannot take the value of a to be 2 here. Because if you take the value of a to be 2, this quantity will become negative, and negative raised to the power of any fraction, this particular things, these type of quantities are not defined by means negative raised to the power of 2 by 3, or negative raised to the power of 5 by 3, or negative raised to the power of let's say 4 by 7, some sort of quantities. These quantities are not defined in real numbers. These quantities are not defined in real numbers. So for this value, a is equal to 2, this quantity will not become a real number. This is not a real number, right? So definitely you have to reject the value of a is equal to 2. So this has to be true for, you have to take only one value. Only one value is left out, so which is a is equal to 0. So that's the answer. A is equal to 0. You can check for here, like if a is 0, this will become what? Half. So half raised to the power of something. Half raised to the power of means half raised to the power something raised to the power of 2. So tending towards 2, basically something half raised to the power of positive quantity raised to the power of 1.9999 something. This is defined, absolutely. Half raised to the power of any positive quantity raised to the power of something raised to the power of any positive fractions power, 2 by 3, or positive raised to the power of 5 by 4 or something. These quantities are defined, definitely. Okay. But negative raised to the power of fractions, these are not defined. Okay. In real number, I'm talking about real number. In real plane, it's not defined. Fine. So that's why a is equal to 0 is the right answer and not a is equal to 2. You know the heading for these type of questions? These type of questions are known as unknown value based questions. Limits answer will be given and you have to solve for the unknown value, which was a in this case. The heading for these type of questions are unknown value based questions, you know, unknown value based questions. These are all categories of questions, you know, from which you get the questions in the mains exam, or be it any exams. You will see that these are some categories, specific categories are there from which you get the questions. Specific categories means unknown value based questions. Then we have some standard forms like 0 by 0, infinity by infinity. Then we have 1 raised to the power of infinity. These are all some places from which you get the questions from. sandwich theorem. Okay, we'll find very rare questions from sandwich theorems, but yes, the questions are very nice. The questions from sandwich theorem are extremely nice questions. So kind of things, these are the subtopics which you need to focus on. I'm telling you, you might note it, you can simply note it down. The ones which are important for your exams, the first one being the 0 by 0 form. Then we have infinite by infinite form. Mostly the questions are based on this thing, these two forms. There are remaining different other forms as well, but these are the most important forms which you'll face, from which every time you'll get the question. Every year we have been getting the questions from here, from these two forms. Okay. Then 1 raised to the power of infinity, this form. Now in these forms only you will face those standard forms, like the standard limits which you will face. Likewise, you are facing over here, right? Sin x by x, tan x by x. Under these forms only you are supposed to face. Then the second portion from second subtopic from which you can get the question. Then we have unknown value based questions. Unknown value based questions. Unknown value based questions. Unknown value based questions. Then the third one being questions involving expansions. Questions involving expansions. These are all subtopics which are taught in class actually. Questions involving expansions. Binomial, as well as that binomial approximation. There are two types of expansion. One is that binomial approximation. One is binomial approximation, and second one is Taylor series approximation. That series expansion which we have seen. Taylor series expansion. Taylor series expansion. And the series problems for the second topic, second subtopic, means unknown value based problems. Use of series is extremely important. It's absolutely favorite of all the entrance exams which you will see after your 12th 10+2. In all the standard entrance exams, this series expansion based questions are extremely popular. The series expansion questions are extremely popular, and you can expect, and the most widely used subtopic in which you will get the series is this unknown value based questions. It's an area in which you will find out maximum in the questions, maximum number of questions are solved using series expansions. Okay, Taylor series or Maclaurin series, what we call as. So you need to remember the series also. Series are what? Basically, series means the expansion of a particular function in terms of algebra. Means the expansion of sin x, cos x, tan inverse of x. These are some standard series. E raised to the power of x. Then we have log 1 plus x. All these series you need to remember. Okay. Then fourth one being sandwich theorem. The fourth one I'm writing over here since we don't have much space. Fourth one being sandwich theorem. These are the 4 points from which widely you will be getting questions actually. Sandwich theorem, sandwich or squeeze theorem. These 4 points are extremely important points from which you will get questions. There are remaining other formats as well, but these are the most important ones. You are bound to get questions from here. Okay. Thoroughly, you see the remaining formats also. Like the remaining formats means infinity minus infinity form is there, right? Then we have infinity raised to the power of 0. All these standard, some of the very standard forms are there. So all those formulas are like x raised to the power of x, limit x tends to 0, x raised to the power of x. Right? Those types of questions are there. Some different formats are also there. Different questions are there. But these are the 4 subtopics from which we have seen the maximum questions from this chapter was given. Okay, let's move to the next question. Look at this. Here, function is given. We have to find the smallest positive integer k such that limit x tends to 0, fx upon x raised to the power of k is not equal to 0. Okay. What is the meaning of this thing? We have to solve for k first of all. We need to find the value of k. If you carefully see, for instance, they are asking for the smallest possible value of k. Means fx is this function. Fx is half times of x sin x and 1 minus cos x. If I divide by x square, let's say, for instance, if I divide by x square, what happens? For instance, if I divide by x square, so this part will become what? Half times of x sin x divided by x square. I'm dividing by x square. I'm dividing by x square. So this will become what? X and this x will cancel out. So you're left out with sin x upon x, right? And this part will become what? Minus of 1 minus cos x divided by x square. That's what will happen. We are dividing fx by x square. So can you see that once you put the limit over here, limit x tends to 0. So this part will become what? Limit x tends to 0. This part will become half times of sin x upon x. This tends to 1, and this will tend to half. So kind of you can say this will become half times of 1, which is half minus half. This will become 0. This will become 0. This will give you the answer to be 0. But they have said answer should not be 0. So you have to say such a value of k for which this limit is not becoming 0. You can start by checking the options, like you put the value of k to be 3 and then verify. The best way to solve this thing is by expansion. The standard way to solve this thing is by expansion. So what I do, I expand this thing, sin x and cos x. Now here I am telling you the standard expansion which you all need to remember is sin x, cos x, then tan inverse of x. Okay, then we have the expansion of e raised to the power of x, then expansion of log 1 plus x. These are some of the standard expansions which you should remember, which you have to remember. These are some standard expansion. What are expansions? These are called Taylor series expansion. Taylor series or Maclaurin series, more specifically. Taylor series also is the popular name. Taylor series expansions. These expansions which you need to remember, these expansions are those expansions by which you can break any function in terms of algebra. Means you can break any function algebraically. You need the algebraic expansion of this. Okay. So likewise here we have sin x and cos x. The expansion of sin x is what? X minus x cubed by 3 factorial divided by plus x to the power of 5 by 5 factorial and so on. Continues. Next term is what? X raised to the power of 7 by 7 factorial. Similarly, the expansion of cos x is what? X minus, like sin x is this, so cos x is just the differentiation of sin x. You know, d by dx of sin x is what? Cos x. So you simply differentiate this series. So what will happen? 1 minus x squared by 2 factorial plus x to the power of 4 by 4 factorial and so on. Some of the series you need to remember, I'm telling you, these are extremely important. And in fact, this question was asked in ISI 2018. So ISI loves series, I'm telling you. Okay. And even if you see the previous year JEE problems, JEE questions also, you will see that some of the questions are solved using series. In fact, in some of the standard exams after 10 plus 2, you will see that the limit questions are mostly based on your series expansions only. So series is extremely important, and you have to remember the series, all these expansion. At least some of the series which is important, you need to remember. Sin x, cos x is there, tan inverse of x is there, e raised to the power of x is there, and log 1 plus x. And parallelly, we also have the binomial approximation, binomial expansion. There was one more term which is called binomial expansion or binomial approximation. You know, binomial approximation for any index. What happens? 1 plus, it is actually approximately, we say this to be, it's basically binomial expansion, but we say it to be binomial approximation. 1 plus nx plus n into n minus 1 divided by 2 into x square and so on. But you need only these 3 terms. That's why we say binomial approximation. Depending upon the question, we use these things. Depending upon the question. For instance, if the question is involving 1 plus x raised to the power of half, something like this, 1 plus x raised to the power of half, then I can think of this binomial approximation. Getting my point? If the question is involving something like this, 1 plus x raised to the power of half, or let's say 1 plus x raised to the power of 3 by 4 or something like this, then I can think of this. You only need the first term. I'm telling you the first 2 terms basically. That is 1 plus 3 by 4 times of x. You don't even need the next terms over here. But sometimes, you know, sometimes we might need this. Depends upon the question. Once again, these are this is once again a separate portion from which questions are asked. Okay. It's called binomial approximation. In a single question, you might have to use binomial approximation also. You might have to use Taylor series expansion also. And maybe you might also have to use the standard forms also. The standard form like sin x by x, tan x by x, all those things. So a lot of questions are possible from here. Okay. It's called binomial approximation. Anyways. Now let's come back to this question. We solve this by series expansion, like fx is half times of x into sin x. So expansion of sin x is x minus x cubed by 3 factorial plus x to the power of 5 by 5 factorial and so on. And cos x is what? Cos x is 1 minus x squared by 2 factorial plus x to the power of 4 by 4 factorial and so on. Okay. So what we do, half times of x into, let's simplify this thing, half times of x into x minus x cube by 3 factorial plus x to the power of 5 by 5 factorial. Okay, let's multiply this also. Let's multiply this x. Let's multiply this x and make this as, let's increase the power. So x into x, that is x square. Then we have x cube, so x to the power of 4 by 4 factorial, and we have x to the power of 6 by 5 factorial. And here we have, you can see 1 and 1, this cancels out. So minus of minus minus plus x square by 2 factorial minus of minus and plus minus of x to the power of 4 by 4 factorial and so on. Right? So we are left out with this thing. So now if we just compare the coefficients over here, you multiply this 1 by 2 also. You will see that 1 by 2 and this x square half and this x square by 2 factorial cancels out. So you're left out with only x to the power of 4 ka coefficient, which is actually what, 1 by 2 times of 1 by 3 factorial. Okay, and then we have minus minus plus 1 by 4 factorial and so on and so on. And similarly the remaining coefficients, like similarly the next coefficient will be of x raised to the power of 6. From here you will be having something x raised to the power of 6 and so on. Next term is what? Next term will be x raised to the power of 8 and so on. You will get the coefficients from here. Anyways, the thing is, what is the minimum power? Can you figure out? The minimum power is x to the power of 4, and it's kind of polynomial by polynomial. So when you divide by x raised to the power of k over here, you have to figure out, that's what they are asking for. Limit x tends to 0. What is this? Limit x tends to 0. What is the minimum value of k for which this answer will be a non-zero quantity? Answer will be non-zero. That's what they are asking. So I'm dividing this directly by x raised to the power of k. If you figure out, here we have the form polynomial by polynomial. It's a format of polynomial by polynomial, polynomial by polynomial, right? The minimum value here, x is tending to 0. So it's a kind of 0 by 0 form. The minimum value for which this polynomial by polynomial form will give you the answer to be non-zero will be 4. What is the reason? We have a format. Do you all remember the format that polynomial by polynomial was there? Polynomial by polynomial and the minimum value, we used to compare the coefficients of the highest power. So minimum power we are going to figure out over here. The minimum value which you need to figure out for which this will give you the answer to be a non-zero. Polynomial by polynomial format, 0 by 0 form, polynomial by polynomial format, answer to be non-zero. Here minimum k has to be 4. Minimum k has to be 4. Minimum k has to be 4. Otherwise this won't be non-zero quantity. This won't be a non-zero quantity. Minimum k has to be 4. If k is less than k, can be some remaining other value also. Minimum k has to be 4. K can be some other value as well, but minimum k has to be 4. K can be 5, k can be 6, but k minimum has to be 4. K cannot be 2, 3 or something. So minimum value k is 4, for which this will give you a non-zero quantity. The rest of the coefficients are becoming 0. That's no problem. This thing, minimum, what was the answer for, polynomial by polynomial? The coefficient of the highest degree. If you all remember, the coefficient of the highest degree divided by the coefficient of the highest degree in the denominator. That's what used to be the answer. One short trick I have taught actually in the chapter of limits, polynomial by polynomial format. Answer to be a non-zero quantity. Answer is not 0. Then what is it? Basically we simply take the coefficient, highest degree ka coefficient. So what is the highest degree? Not the highest degree. Here they have asked, the question is different. The question is the smallest positive integer k for which this will be the non-zero. So smallest positive, definitely the smallest positive has to be 4 here. Okay, smallest positive integer has to be 4 here. So k definitely must be 4. Option B is correct. Okay. All right, let us move to the next question. Okay, once again, a question from a standard format of limits. It's a very basic question. Do pause the video and please do try this question. It's a very basic question, and I hope you know from which form they have asked the question. Okay, so this question is from actually which format? As you put the limit, x tends to 0, this will become 0, tan pi by 4, which is 1, 1 raised to the power of 1 by 0, infinity. So 1 raised to the power of infinity form. 1 raised to the power of infinity form ka question. This is a question from 1 raised to the power of infinity. How do we solve this? I hope you remember that limit x tends to 0, there is a direct formula, right? Limit x tends to a, let's say. Fx raised to the power of gx is there. Upon putting the limits, fx tends to, let's say, fx tends to 1, means after putting the limits, fx tends to 1 and gx tends to infinity. After putting the limit, as x tends to a, fx tends to 1 and gx tends to infinity. So we have the form 1 raised to the power of infinity. So if these things takes place, then what is the formula directly? We write it as e raised to the power of limit x tends to a, gx comes down, and we write it as fx minus 1, right? That's how we write it. So here, similarly, here also we have the same format, 1 raised to the power of infinity. So what is it basically? So we use the same logic. So e raised to the power of, directly we use the form e raised to the power of limit x tends to 0, right? Done. Then we have gx will come down. This is gx actually, and this is fx. So gx comes down. So 1 by x comes down. Then we have fx minus 1. So fx minus 1 means tan pi by 4 plus x minus 1. Tan pi by 4 plus x minus 1. That's what we have. So now once again, this power, e raised to the power of something is there. So this power once again turns out to be standard limits. Now we solve this. Now that's easy to solve. Limit x tends to 0, what we are having? Limit x tends to 0. You can clearly see. Just if we rewrite this a bit, minus 1 divided by x. So can you figure out, as x tends to 0, this will actually become pi by 4. Tan pi by 4 is 1. 1 minus 1 divided by 0. So 0 by 0 form once again. Now we can solve. We can solve using this L'Hopital's rule. Once you differentiate this thing, so this will become limit x tends to 0. And this will become what? Sec square pi by 4 plus x divided by 1. So now the form is gone. So we have e raised to the power of limit x tends to 0. You put the limit over here. So limit x tends to 0 means this will become 0. Sec square pi by 4. Cos pi by 4 is basically 1 by root 2. So we have sec square pi by 4, which is root 2 whole square. So root 2 whole square is basically 2 only. So e square is the answer. Okay, a very basic question asked in JEE Mains 2020. And it's a kind of very routine questions. You know, these questions are very routine questions. This format, these type of questions we have already solved in class. Tan pi by 4 plus x raised to the power of 1 by x. Okay, it's a kind of very routine question you can see. All right, let's move to the next question. Okay, now we have this question from ISI 2018. The question says that consider two distinct APs, each of which has a positive first term and a positive common difference. Sn and Tn be the sum of the first n terms of these AP, then we have to find what is limit n tends to infinity Sn by Tn. Okay, let us see. So we have limit n tends to infinity. Sn is what? Sn is the sum of the n terms of the first AP. We consider two APs basically. We have to consider two APs. Okay. And Tn is what? Tn is basically the sum of the n terms of the second AP. So for the first AP, since we have a positive AP, so positive first term and positive difference, common difference. So for the first AP, I consider the first term to be A and D. And similarly for the second AP, I consider the first term to be capital A and capital D, let's say, common difference. Okay. So for the first AP, the sum of n terms is given by Sn. And for the second AP, the sum of n terms is given by Tn. Both of them are having n number of terms. So Sn is what? N by 2 times of 2A plus n minus 1 times of D by the sum of n terms of the AP formula. And here we have Tn is what? N by 2 times of 2 capital A plus n minus 1 times of capital D. Now they're asking us to find out what is limit n tends to infinity Sn by Tn. Sn by Tn. So what will happen? So let's put these values over here. So limit n tends to infinity. Sn by Tn means n by 2 times of 2A plus n minus 1 times of D divided by n by 2 times of 2 capital A plus n minus 1 times of D. So n by 2 and n by 2 cancels out. So here we have limit n tends to infinity. This will become what? This will tend to infinity. Infinity plus something which is infinity only. And here also this will tend to infinity. So this is of the form infinity by infinity. So whichever how do we solve these type of questions? Whichever format, whichever part is tending to infinity, it's better to divide by that part. So here n minus 1 is tending to infinity. So what we do? We divide by this n minus 1. So this becomes limit n tends to infinity. 2a upon n minus 1, and here we have plus D divided by 2 capital A divided by n minus 1 plus capital D. So now can you figure out that this quantity 2a is a positive quantity, all these are positive quantities. Positive quantity divided by infinity, this will tend to 0, this will also tend to 0. So what is the answer? Answer is D by D. D by D. And what is D by D? The common difference of the first, ratio of their common difference. It's basically the ratio of the common difference of the first AP and the second AP. So what is it? Option D is correct. The ratio of the common difference of the AP, the two APs. A very simple question. You know the formula, you know the techniques. It's a very basic question. It takes time to more of a time to read the question, just to read the question. Okay. The workings just hardly takes few seconds. All right, let's move to the next question. Now let us solve few questions from unknown value based problems, some typical unknown value based questions. Unknown value based questions. Once again, unknown value based questions. Now I'm telling you here in this section, you will find most of the questions are based on this section only. And here, the most of the questions are solved using basic expansion, expansions of series expansion. Most of the questions are solved by series expansion. Means expansions are extremely important, at least for this heading. Expansion is extremely important for this heading. Look at this. We have this limit given, and this is equal to 1. We have to solve for A and B. Somebody has solved this limit. They have given the answer to be 1. We have to solve for A and B. So what I do, first of all, one thing which you need to figure out is till where I'll expand. This will decide the one which is there in the denominator. Like x's cube is there. So I'll expand till the term I am obtaining x's cube. Likewise over here, you focus on this term. Sin x is there and cos x is there. So basically we are supposed to expand this thing. Expansion means we have to expand any function and bring in terms of algebra. Algebraic expansion rather. So sin x ka expansion is given by x minus x cube by 3 factorial plus x to the power of 5 by 5 factorial and so on. And the expansion of cos x is just the differentiation of this series, which is 1 minus x square by 2 factorial plus x to the power of 4 by 4 factorial and so on. Now see, here we have limit x tends to 0, x times of 1 plus a cos x. So x times of 1 plus a cos x, a times of cos x. Expansion of cos x is 1 minus x square by 2 factorial plus x to the power of 4 by 4 factorial and so on, right? But we don't need this term, x to the power of 4 by 4 factorial. We'll expand only till here. Why? Because outside, you figure out, outside we already have one x over here, right? So x times of this quantity will make it to be x's cube. And in the denominator, we are already having one x's cube. So we'll keep up only to this. 1 minus x squared divided by 2 factorial. Only this much we'll expand. Not more than this, okay? Fine. So then we have minus of b times of sin x. b times of sin x. Now sin x is what? X minus x cube by 3 factorial. That's all. The first two terms only. Because in the denominator, we are having x's cube. Okay? Only this much we need. So what we get from here is basically we are having limit x tends to 0. Next, what you are supposed to do? Right hand side, we have 1 by 1 only. Right hand side, we have 1. Next, what we are supposed to do? We are supposed to separate the coefficients. Coefficient of x, the degree terms basically, the coefficients of x we have to separate and the coefficient of x square. We separate this, we modify this a bit. Here we have x. Some coefficients of x will come over here and coefficients of x square we are going to compile over here. Okay, x is cube. Now see, here we have x. X means 1 plus a, and then from here also we'll get b, minus b. And similarly, the coefficients of x cube will be what? This will become what? Minus of a times of minus a, so minus of a by 2 factorial. And the coefficient of from here also, you will get minus of minus plus b by 3 factorial. These are the coefficients of x cube. So divided by x cube. Why we have done this? Now you carefully see. Now the main things come. So here, if you carefully see that limit x tends to 0, all these will tend to 0. Once you divide these things individually, this x cube and x cube will cancel out. There is no problem. Right hand side is a finite quantity 1. But once you divide this quantity individually, if you divide this quantity 1 plus a minus b into x, x divided by x cube will become x 1 by x square, and x is tending to 0. Something by x square, we are having x square in the denominator, x is tending to 0. So something by 0 will become, this will tend to infinity. Right hand side we have 1. This answer won't be 1. Answer won't be 1 in that case. Okay, so definitely this quantity needs to be 0. This quantity needs to be 0, means 1 plus a minus b has to be 0. 1 plus a minus b has to be 0. Or basically a minus b must be equal to minus 1. Okay. Similarly, if you divide this and this, x cube and x cube will cancel out. You will be left out with this constant quantity only, a upon 2 factorial plus b upon 3 factorial. Okay. At right hand side, we are having 1. So technically, you are getting two relations. You are getting two relations. First relation is this, and this is the second relation you are getting. You're going to solve a and b simultaneously. We are going to solve for a and b, small a and small b. Okay. Simultaneously solve these two relations and obtain the value of A and B. That's all what you need to do. Okay, I'm leaving this calculation for you all. Please do solve the value of A and B and tell me. Okay, simultaneously you just need to solve this thing. You can modify this further. What is this? Basically minus of A by 2 plus B by 6, and this is equal to 1, and simply modify and simply solve for A and B from here simultaneously. That's very basic one. Okay, now this much you all can do. Let's move to the next question. These are very, very important questions. I'm telling you, extremely important. Now, this was a straightforward question. Straightforward means in the denominator, x's cube was clearly visible. X's cube was there. So accordingly, I have to expand this much. You won't be getting x's cube every time. I'm telling you, means every time the terms are clearly visible, like till how much we have to expand, every time that won't be given. So they'll try to twist and turn this particular scenario. Let's see what happens. You look at the exam question from here, JEE Mains 2022. Look at this thing. Here we are having beta is given to be this limit. Once again, 0 by 0 form is there. We have to find the value of alpha plus beta. Okay, so we have beta is this limit. So beta is basically limit x tends to 0. Alpha x, once again, we have e raised to the power of 3x. So what I do, look at this very carefully. Alpha x minus e raised to the power of 3x minus 1. Divided by alpha x times of e raised to the power of 3x minus 1. Our standard form is known to us. Limit x tends to 0. E raised to the power of x minus 1 divided by x is basically 1. But here we are having 3x. So what? We can simply bring in this way, like e raised to the power of 3x minus 1, we can divide it by 3x. And x tends to 0, so 3x also tends to 0. Okay, same by e raised to the power of same divided by same. And upon putting the limit, this thing will tend to 0. So upon putting the limit, 3x tends to 0. Okay, but here we have taken forcefully, we have taken 3x, right? So we have to divide also, we have to multiply also. We have divided by 3x, so we have to take one extra 3x over here. So make this as 3x square. Okay, fine. So now can you see that once you separate the limit, this quantity will become 1. This will become 1. So you are left out with what? Limit x tends to 1, x tends to 0, alpha x minus e raised to the power of 3x minus 1 divided by 3 alpha x square. So now can you see the number? This 3 alpha is a constant. So now this number is clearly visible. This thing is clearly visible, that how much we need to expand. X square is there, right? So we need to expand e raised to the power of 3x for just 2 terms only, till the x square terms. What is the expansion of e raised to the power of x? Once again, I'm telling you, expansions are extremely important. You need to learn expansion. E raised to the power of x is what? 1 plus x square by 2 factorial and so on, so on. So you just need only the first 3 terms till x square, right? So what is the expansion of e raised to the power of 3x? Just in the place of x, right? In the place of x, you simply replace by 3x. In the place of x, in the first series, you simply replace by 3x. So x plus 3x, 1 plus 3x plus 3x whole square by 2 factorial and so on. Okay. For instance, if you would have needed the expansion of e raised to the power of minus 3x, what you would have done? You would have simply replaced the value of x by minus x. That's all. Okay. So now what is this? 1 plus 3x whole square divided by 2 factorial and so on. So what is this now? So limit x tends to 0. Alpha x minus this thing. So alpha x minus expansion of e raised to the power of 3x, which is 1 plus 3x plus 9x square divided by 2 factorial. That's all. And then minus 1 divided by x square and then 3 alpha. You only expand to the terms the terms based on which is there in the denominator. Okay. So limit x tends to 0. What is this basically? So 9x square divided by 2 factorial and 3x, 1 and minus 1 cancels out. So we have alpha x minus of 3x. Let's simplify this thing. What we do? We simplify this thing. We separate the coefficients of x. That's what we do. The same procedure follows. Separate the coefficients of x and x square. Separate the coefficients of x and x square. X is what? Alpha. Alpha and then what? Minus 3 from here. Alpha minus 3. And similarly here we have minus and plus. We have minus. So we have 9x square over here, right? So minus of 9 by 2 factorial. Minus of 9 by 2 factorial. That's what we are having. And divided by 3 alpha x square. 3 alpha x square. Okay. So here alpha belongs to all real numbers. Once again, the same similar logic. We have beta. this quantity equals beta. Beta must be a finite quantity. Obviously, beta must be a finite quantity. So definitely for this to be a finite quantity, now this as x tends to 0, this will become what? X upon x square. X upon x square will make it to be 1 by x, and x tends to 0, 1 by x is tending to infinity. So definitely this cannot tend to, means this quantity, this has to be 0. Which quantity has to be 0? This quantity, alpha minus 3 has to be 0. This has to be straight away 0. So alpha minus 3 definitely must be 0. So if alpha minus 3 is 0, means alpha is basically 3. Alpha has to be 3. So if alpha has to be 3, so definitely, now this will not create the problem. This won't create the problem. Minus 9 factorial divided by 3 alpha. Minus 9 by 2 factorial means 2 only, and divided by 3 alpha, right? This quantity, once you divide this thing, x square and x square will get cancelled. This will get balanced. There is no problem, right? And this will be beta only. Now we have got the value of alpha to be 3. So just simply put it over here. So 3 into alpha, which is minus of 9 by 2 times of 1 by 3 alpha means 1 by 9. So 9 and this will cancel out. So we have beta to be minus half. So what is the value of beta? Beta will be minus half. So we have got alpha also. What is alpha? Alpha is basically 3 and beta is minus half. So we find what is alpha plus beta, which is actually 3 minus half. So which is 5 by 2. Got it? A very basic question, straightforward question. Okay, you do the same thing. You expand this, separate the coefficients, and simply compare. So the thing is over here, what you need to mainly focus on is this thing. Like as I said in the previous question, x square was clearly visible. Every time x square or x cube, x to the power of 4, the denominator powers might not be clearly visible. So you need to bring into that format. Likewise here, what we are doing, x square was not initially, x square was absent over here. So we are bringing into some standard, using some standard form, we are forcefully bringing x square over here. Likewise, what we have done. Let's see some more questions of this type. Look at this now. Asked in JEE Mains 2023. Lots of things have been given. Cos bx is there. Okay, then cos 2x is there. One by one, let us see what we can do from here. E raised to the power of minus cx is also there. Exponential function, cos function, everything is there. So can we think of using some sort of standard form? Likewise, they are asked to find out the value of 5a square plus b square. So one thing which I can clearly see is likewise 1 minus, we know the format, limit x tends to 0, 1 minus cos x divided by x square. This is basically half, right? Here we are having 1 minus cos 2x, no problem. So we have the same by same square format, right? 1 minus cos, whatever it is, divided by the same format, whole square must be there. And upon putting the limit, this must tend to 0. That's what we need. So we can say the answer is basically half. So technically, we can do the same thing over here. Why? We have limit x tends to 0 divided by 1 minus cos 2x. So 1 minus cos 2x means we can divide by 1 minus cos 2x. And we can divide by 2x whole square. So 2x whole square we are dividing with, so we have to multiply also. 2x whole square. Forcefully we have taken this 2x whole square, right? Fine. So what we can do is, and upon putting the limit x tends to 0, this 2x also tends to 0. So this quantity will become half. This will become half. So you are left out with what? In the denominator, you focus only on this part. In the denominator, you are left out with, I'm writing it over here. So we have limit x tends to 0. In the denominator, we are left out with 2x square into 2x square. Here we have 2x square means 4x square into half. So means 2x square is left out. See, you have reduced it into 2x square, right? So you have reduced it into 2x square. And then what is there in the denominator? In the numerator, we are having e raised to the power of ax minus cos bx minus of cx into e raised to the power of minus cx divided by 2. That's what we are having. Okay. And right hand side must be a 17. So we have modified this. Now in the denominator, we are having x square. So only till the term we are obtaining x square, till that much we are supposed to expand. Expansion of e raised to the power of x. Once again, I'm writing 1 plus x square by 2 factorial and so on. Then we have cos x. Cos x is what? 1 minus x square by 2 factorial plus x to the power of 4 by 4 factorial and so on. Right? So here we are having cos bx. So wherever we have x, we are supposed to replace by bx. Similarly, here we are having e raised to the power of ax. Wherever we have x, we are supposed to replace by a. So we have limit x tends to 0, limit x tends to 0, e raised to the power of ax, e raised to the power of ax means expansion of e raised to the power of ax means 1 plus ax plus a square x square by 2 factorial. That's all till x square. Minus of cos bx. What is cos bx? 1 minus b square x square by 2 factorial. That's all. Okay. Similarly, we have minus of cx by 2, and then we have the expansion of e raised to the power of minus cx, which is minus 1 minus cx. Only cx, 1 minus cx, only two terms are needed. Why? Cx into cx or x into x will become x square. In the denominator, we are having 2x square or x square is there. So only till x square terms we need. Okay. Okay. Now what we can do from here? Now the same logic, we can see some sort of cancellations getting generated. 1 and minus 1 cancels out. So now the same logic, you separate the coefficients of x and then the coefficients of x square. You can clearly see the coefficient of x is getting generated. Coefficient of x is what? Ax, right? Coefficient of x is what? A. Then from here we are having minus of cx by 2, so minus of c by 2. And from the coefficient of x square, we have a square by 2 factorial. And from here we are having minus plus b square by 2 factorial. Plus b square by 2 factorial. And similarly from here also we are getting cx into cx square, so c square by 2 factorial. Right? Minus plus c square by 2 factorial. C square by 2 only. So that's 2 factorial and 2 has the same value anyways. Divided by 2x square. Limit x tends to 0. Right hand side we have 17. So now can you solve from here? The same logic, x upon x square, this will tend to, x is tending to 0. X upon x square, this will become something by x. This will tend to infinity. So definitely this cannot be accepted. So a minus c by 2 has to be 0. So one relation we are obtaining, a minus c by 2 has to be 0. Otherwise, the answer will not be a finite quantity. On the right hand side, the answer is 17. Okay. So answer won't be 17 if this is not 0. This has to be 0 for this to be a finite quantity. And what are the remaining ones? From here, you are getting one relation. A is basically c by 2, right? Or more specifically, 2a is c. And what else we can say from here? What else can we say? We are having this quantity now. So 1 by 2 times of 2 is there, right? So 1 by 2 times of this entire thing, x square and x square will cancel out. No problem with this, right? So 1 by 2 times of this will become a square plus b square plus c square divided by 2 factorial, 2 factorial and 2. So 2 over here divided by 2. This is equal to 17, right? So a square plus b square plus c square. A square plus b square plus c square is what? 17 times 1 by 2 times of 2, which is 17 times 4 you will be obtaining. So 17 times 4, this is actually 68. Okay, and we have the value of a square plus b square plus c square, and further we can actually solve for a square c square from here. We have solved c is what? 2a. C is 2a, so simply put it over here. So a square plus b square plus c square is what? 2a square, means 4a square. And 4a square plus a square will give you 5a square. So you will be getting 5a square plus b square. 5a square plus b square will give you 68. 5a square plus b square will give you 68. Okay, and that's what they are asking for. In the question, they have asked for the value of 5a square plus b square, and that is 68. Okay. Once again, a nice question, but a similar type of problem. I'm telling you directly, every time they won't give you directly x cube or x square. You have to bring into that format. You yourself have to think of that format. I have to bring into that format, and then I have to simplify. Okay. 1 minus cos 2x is there, whatever it is. We need to bring one x square, x cube, something we have to bring in the denominator on the basis of which I can decide till where I have to expand. That is the main target.